Namaste, welcome to my channel Video.Guru. My name is Surya. If you haven't yet subscribed my channel, please hit the subscribe button. So today's class will be going for discussing the operating system. The definition for the operating system, and what are the various kinds of scheduling algorithms. We will be going for discussing that. First, define the operating system. So what is an operating system? Okay. So operating system is a system software. Right? Try to understand. Operating system is a system software which is responsible for managing and controlling all the resources of your computer system. Resources are maybe your hardware resources. Resources are software resources also. Okay, understood? So this is the definition for operating system. Operating system is a system software which is responsible for managing and controlling your hardware resources and software resources of your computer system. It is responsible for managing and controlling your all the hardware resources and also the software resources of your computer system. This is the definition for your operating system. Understood? So we will be discussing about the scheduling algorithms. So before discussing the scheduling algorithms, I want to discuss some important terms so that it will be useful for the study, right? So we will be discussing about the scheduling algorithms. So there are 4 scheduling algorithms we will be going for discussion in details. Like your FCFS scheduling algorithm, we will be discussing about the shortest job. Next, scheduling algorithm, SJN scheduling algorithm, what we call, okay, in short. Then we will go for discussing the priority scheduling algorithm. Then we will go for discussing the round robin scheduling algorithm. Okay. So before moving towards the scheduling algorithms to discuss in details, let us first of all try to understand the very important terms that is being used repeatedly in the further topics. Okay, so what are those important terms? The first one is CPU scheduler. CPU scheduler, and one more is your process scheduler. Process scheduler, or this you call it as a OS scheduler also, operating system scheduler. Okay. So what is a scheduler? So try to understand what is a scheduler. Okay. Scheduler is a system software again, right? Scheduler is a system software which is responsible for scheduling your processes or jobs to get executed in your CPU. Okay, so it will be systematically schedule the job. It will be systematically schedule the processes to get processed in your CPU. Right? So it is a system software. Right? So CPU scheduler. So when the processes will reach to the CPU and how the processes will be getting executed in the processor, that will be decided by the CPU scheduler inside the CPU. Okay, processor, right? Operating system or process scheduler. So let's see, a process scheduler can be of other types also, like we are having the long term scheduler, short term scheduler. Okay, so forget about that. Try to understand what is the process scheduler. Okay, process scheduler or the operating system scheduler is responsible scheduling the job or the processes outside the processor, right? So how the processes will be moving to the processor. Inside the processor, the CPU scheduler will be scheduling the job and allocating the processes to the processor, right? Operating system or the process scheduler is responsible for taking the job or scheduling the job outside the processor in the primary memory. Okay, so as the processes will be coming to the primary memory and entering into the processor for execution, right? So in the primary memory, how here processes or jobs will be placed, so that the particular job will be going to the processor for execution. Are you understanding? It is outside the processor. So your operating system scheduler, or you call it as a process scheduler, that will be responsible for scheduling or managing or maintaining the job or the processes that has to be executed in the CPU. Okay, that is waiting for execution in the CPU. Okay, so some certain in a certain manner it has to be managed and kept in the primary memory. Okay, so that one, how it will be doing that, they will be, the operating system will be managing and controlling the processes by using the scheduling algorithm. Okay, scheduling algorithms. So we will be going for discussing these scheduling algorithms. Okay, these scheduling algorithms, we are going for discussing the FCFS scheduling algorithm. We are going for discussing the SJM, shortest job next scheduling algorithm. We will be going for discussing the priority scheduling algorithm, and we will go for discussing the round robin scheduling algorithm. Okay, so this algorithm has to be followed before entering into the processor for executing the processes. Okay, so inside the processor, the CPU scheduler will take care of. Okay, see, CPU processor can be of dual core, quad core, octa core. Okay, so according to the capacity of the processor you have used, the processing speed will be fast. If you are having the dual core, your processor, you have used the dual core processor, that means it is having the two cores. Okay, so that means at a same time two processes can get executed. Are you understanding? If you are using the quad core processor, four processes can get executed simultaneously. If you have used octa core processor, then simultaneously 8 processes can get executed simultaneously. Okay, so nowadays your processor and your operating system are multi-programming and multi-processor and time sharing systems. Okay, so anyhow, if you are using the high capacity processor, your speed of execution will be more. That means the output that you are getting in your computer speed is very fast. Understood? So it depends upon the processor. So what capacity of processor you have used in your computer system. Okay, so that one. Okay, so your CPU scheduler will be responsible for scheduling the job or scheduling the processes inside the processor and finally executing inside the processor. Okay, that thing. Okay, so our main topic is, we will be going for discussing the FCFS, SJM, priority and round robin scheduling algorithms. Scheduling algorithms. Okay, so algorithm. Okay, so let us start. So first come first serve scheduling algorithm, or in short we call it as FCFS scheduling algorithm, is a non-preemptive scheduling algorithm. Okay, so try to understand what do you mean by preemptive. Preemptive and non-preemptive meaning. Okay, so what do you mean by preemptive scheduling algorithm? What do you mean by non-preemptive scheduling algorithm? Okay, so I am telling that FCFS, first come first serve scheduling algorithm, is a non-preemptive algorithm. Non-preemptive algorithm means that when a particular process is executing in the CPU, it cannot come out from the CPU unless and until it completes its execution fully. Okay, are you understanding? Non-preemptive means a process has entered into the CPU for execution, right? It will be executed, right? It will be executed until it completes its execution fully. Okay, so for example, its execution time for that particular process is 10 nanosecond, 10 nanosecond. Okay, the process has entered into the CPU, right? So that process will be executing in the CPU until it completes, till its completion. Okay, so when it has executed the 10 nanosecond, then only that process P1 will be coming out, printed out. Okay, are you understanding? Right now, what do you mean by preemptive? Preemptive means when a process enters into the particular processor. For example, the process execution time is 10 nanosecond for that process. Okay, the process will be executing in the processor. Right now, another process enters into the processor which is having the high priority than the processor which is executing right now. Okay, another processor which is having the high priority that wants to enter into the processor, then in that situation the process which is executing in the processor will be printed out. For example, that particular process which is executing at present has executed 5 nanosecond. Still 5 nanosecond is left out. Okay? That process, when another high priority process tries to enter, that high priority process will be taking the priority for executing into the processor. Now the low priority, okay, which is executing right now, that will be printed out, that high priority processor enters into the CPU and gets executed. Okay, that kind of algorithm you call it as a preemptive. The process has not completed its execution and it comes out from the processor when the high priority process tries to enter into the processor. Okay, that kind of algorithm is known as a preemptive. Non-preemptive means it will execute until it completes its execution. Okay, so you understood what is the preemptive and non-preemptive? Okay, so here FCFS scheduling algorithm is a non-preemptive scheduling algorithm. That means what? It will execute until its completion. Okay, understood? So it's a non-preemptive scheduling algorithm. Okay, FCFS algorithm follows the FIFO rule. FIFO rule. FIFO. FIFO. First in, first out. Okay? It follows this particular rule. FIFO. Okay? First in, first out. Which process has been entered first into the processor will be coming out from the processor first. Then next process. Then coming out. Then next process. First in, first out. Okay? By the name insert, you come to know FCFS, first come, first serve. That means which process will be coming first, that process will be served first by the processor. Okay, understood? What is the FCFS? And it follows the FIFO rule. First in, first out. And it's a non-preemptive algorithm. Okay, so up to now it is clear? Right. So let us see this table. Okay. Process P0, process P1, process P2, process P3 is trying to enter into the processor for execution. Okay? Right now, here one term is there. What do you mean by a program and a process? So here it's a process, right? So what is a program and what is a process? Try to understand the difference between these. So what is a program? Program is a set of instructions. Okay? It is a set of instructions which is stored in your hard disk, and it is in a passive state. Understood? It is a set of program, a set of instructions. Program is a set of instructions which is stored in your hard disk and it is in a passive state. That is called as a program. What is a process? When this particular program from the passive state that was stored in the hard disk comes and gets loaded into your primary memory. That program is known as the process now. Right now the process is in active state. Okay, the process is in active. That means it is ready to be executed. So it comes to the primary memory. So you know the direction of execution, right? So whatever the execution has to happen in the CPU, it has to be coming through the RAM, primary memory. So there setup is being done, then it enters to the CPU where the processing activities happens, then your output comes to the monitor. Okay, so this is the way. Okay, so right now the program which is sitting in the idle state in your hard disk, when it is being loaded into the loaded into the primary memory, it becomes the process. Right? Now, the process is a small chunk of the program, the same program, small chunk. Okay, so why it is being divided into small chunks? Your operating system tries to manage and maintain and control all the programs that has come to the primary memory. So how it does? What the operating system does? The operating system. That's why I said you the process scheduler. Okay, here the process scheduler plays a very vital role. Okay, so right now the process scheduler of the operating system, what it does, it divides the particular program into small parts, small chunks. Okay, and that small chunks of the program is called as the process. Okay, and that particular processes are ready for execution. Okay, that means previously it was in not running state. Now it comes for running state. Okay, it changes the state. Okay, not running state, running state. Okay, that is the process. So see, I have taken a small example over here. I have taken a small example over here. What is that? A program has been the operating system has divided the program which was sitting in the hard disk in a passive state. The operating system has converted that particular program and loaded it into the primary memory. It has divided the particular program into four processes. Okay, so that is being loaded into the primary memory, and those four processes are P0, P1, P2, P3, and these are ready to enter into the CPU or the processor for execution. Right? Now, they are ready. Now they will start entering into the processor. Right? P0 arrives into the processor at 0 time, that is nil time, starting time. Okay, and P0 takes 5 nanoseconds for execution. Okay, Then P1 enters into the processor at 1 nanosecond and takes 3 nanoseconds for execution. P2 enters into the processor at 2 nanoseconds, okay, and takes 8 nanoseconds for total execution, right? P3 enters into the processor at 3 nanoseconds and takes total 6 nanoseconds for execution of process P3, okay. This you understood, this table, okay. Moving to this table, okay. See here, P0 started at what time? At 0 time. It has taken how much time for execution? 5 nanoseconds. So I have shown here. P0 starts executing into the processor. See here, CPU scheduler takes a very important role. Okay, see, all the processes has entered into the processor. Now it is scheduling. It is scheduling accordingly. Okay, as FCFS is a non-preemptive algorithm. P0 enters into the processor, executes totally, takes 5 seconds. As it is a non-preemptive, it cannot come out until it completes its execution, right? So 0 time started, 5 completed. P0 comes out. At 5 nanosecond, P1 enters and start executing. Okay, so it takes how much? 3 nanoseconds to complete its execution, P1, right? So it takes 3 nanoseconds and completes at 8, right? Now P1 comes out from the processor, now P2 enters into the processor for execution. So P2 takes how much time? 8 nanoseconds for fully execution. So 8 to 16, how much? 8, right? Right? So it takes 8 nanoseconds for fully execution. It completes in 16. Now P2 comes out from the processor after fully execution. Next P3 enters into the processor for execution, right? So P3 enters, it takes how much? 6 nanoseconds for execution, right? So it takes 6 nanoseconds for fully execution. So right now at time 22, the full program execution has been completed. It started at 0, completes at 22. Okay? So it has followed the FCFS scheduling algorithm, right? And it has executed. As FCFS is a non-preemptive, no processes can come out until it completes its execution. So every processes has completed their individual execution and coming out from the processor. So finally the full program is executed at time 22. Okay? Understood? So let us try to find out the waiting time of individual processes. Okay? Individual processes waiting time. So P0, what is the waiting time for P0? As P0 has entered first, so there is no waiting time, right? For P0. Waiting time is to acquire the processor for execution, to get the processor to execute. Okay, as P0 was the first process to come to the processor, so P0 is not waiting for the processor. It has got the processor for execution. So there is no waiting time for the process P0, right? Next, P1. What is the waiting time for process P1? Process P1 waiting time is 4 nanoseconds. How it came? Okay, 4 nanoseconds. 4. The waiting time for the process P1 is 4 nanoseconds. Okay, so try to understand. 5 minus 1. Okay, 5 process P0 has taken for execution, right? 5 is the process P0 has taken the time for execution. When process P0 was executing, P1 has not arrived till it. It has arrived at 1. right? P0 is executing until P0 has completed 1 nanosecond, then P1 has arrived. Okay? P1 has arrived at 1 nanosecond, but P1 was not waiting for the processor till 1 nanosecond, right? After 1 nanosecond only P1 has arrived. So what is the total waiting time for P1? 5 minus 1. 4. So P1 has waited for the processor for 4 nanoseconds only. Are you understanding? It's clear, right? It has waited for P0 taken 5 nanoseconds. P1 has arrived at 1 nanosecond. So what is the waiting time for P1? Only 4 nanoseconds. 5. Total execution time of process P0 5, as P1 arrived after 1 nanosecond of P0 execution. So till here, P1 arrived from here, 1 nanosecond has already completed. P0 has already completed 1 nanosecond, right? Then P1 arrived here. It was waiting for the processor. So it has to wait for the processor. Because P0 has to complete, then P1 can execute, right? So now, when P1 arrived here, so how much time it will be waiting? It will be waiting for only 4 nanoseconds until P0 completes its execution, right? So that you understood, right? Now P2. What is the waiting time for P2? 8 minus 2. Okay, waiting time. It has started at 8, right? But P2 waited for how much time to acquire the processor? P2 waited for, because it has entered at 2 nanoseconds, right? So what is the total waiting time for the P2? 8 minus 2, 6 nanoseconds. So P2 waited for 6 nanoseconds to acquire the processor. Is clear? Now, P3. So what is the waiting time for P3? 16 minus 3, because P3 entered at 3 nanoseconds. So P3 entered at 1, 2, 3. Here P3 entered into the processor and waiting for the processor to get executed. Okay, waiting for the processor. So it is waiting until P2 completes. Then P3 can enter into the processor. So what is the total waiting time? 16 minus 3 for the process P3. Okay, 16 minus 3 is the 13 nanosecond the P3 has waited to get the processor. So what is the average waiting time? Average waiting time. What's the average waiting time? Average waiting time is 0 plus 4 plus 6 plus 13 divided by 4. So you calculate it and you can get the average waiting time for the processes. Okay. So this is about the FCFS scheduling algorithm. I hope you understood. So in the next class we'll discuss about the priority scheduling algorithm and also the round robin scheduling algorithm and also the SJN scheduling algorithm. Okay. So for the time being I am stopping today's class. So we'll meet